So today I want to talk about triangles. First of all, let's go ahead and define the term triangle. A triangle is a two-dimensional object made up of three sides and three angles. The vertices of a triangle are the points at each peak. So the vertices are F, G, and H. The angles here are also angle F, angle G, and angle H. The sides that make up this triangle are the segments that connect the vertices. So segment FG, segment FH, and segment GH. There are two different ways that we classify triangles. We can classify triangles according to sides and according to angles. There are three classifications by side. The first classification by side is called scalene. A scalene triangle has no congruent sides. The second classification by side is isosceles. An isosceles triangle has two congruent sides. And the final classification by side is equilateral. An equilateral triangle has three congruent sides. All sides are congruent. Now, we can also classify triangles by their angles. There are four classifications according to angle. The first one is acute. An acute triangle has three acute angles. Remember, acute angles are less than 90 degrees. The second type of classification according to angle is obtuse. An obtuse triangle has one obtuse angle. Remember, an obtuse angle is greater than 90 degrees. So we've talked about all less than 90, one greater than 90. A right triangle has one 90-degree angle, one right angle. And then the final classification according to angles is equiangular. An equiangular triangle has three congruent angles. Okay, a reminder of a property that we learned in Algebra 2, but the sum of the measures of the interior angles of a triangle is 180 degrees. So if we add the measure of angle F to the measure of angle G to the measure of angle H, that will always equal 180 degrees. Okay, some corollaries to this. Remember, a corollary is just a statement that can be proven true based on a previous statement, but it's not exactly a new result. So the first corollary says if two angles in one triangle are congruent to two angles in another triangle, then the third angles are congruent. Now, that should make sense, right? Because if we know two angles of one triangle, we can figure out the third because they have to add to 180. So if we have two of the same angles in two different triangles, that means the third angle has to be the same. If we have a 100-degree angle and a 30-degree angle, the third angle is forced to be 50 degrees. If we have a 100-degree angle and a 30-degree angle in another triangle, the third angle still has to be 50. Each angle of an equiangular triangle is 60 degrees. We know an equiangular triangle has all congruent angles, and since they have to add to 180 and they're all congruent, each angle is 180 divided by 3, which is 60 degrees. Third corollary, in any triangle, there is at most one obtuse angle or one right angle. The reason this has to be true in number 3, since we have 3 angles that have to add to 180 degrees, if we have one obtuse angle, that means it's more than 90 degrees, so both of the other angles have to be less than 90 degrees. We can't have 2 obtuse angles because then we would have a sum that's bigger than 180. The reason we can't have more than one right angle, again, is similar. If we had 2 right angles, then the sum would be 180, and we wouldn't have any angle measure left for the third angle. And the fourth corollary, the acute angles of a right triangle are complementary. Okay, if we have a right triangle, okay, we know that one of the angles has to be 90 degrees. Okay, so we know the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. But we know the measure of angle C is 90, so the measure of angle A plus the measure of angle B plus 90 equals 180. Subtraction of 90 from both sides gives us measure of angle A plus measure of angle B equals 90, which is the definition of complementary. Okay. The exterior angle of a triangle is an angle formed outside of a triangle adjacent to one of the interior angles. So this angle right here would be the exterior angle of this triangle. Now, one way to think of an exterior angle of a triangle, it's formed when one of the sides, like right here, is extended. Okay, so when we extend one of the sides, we get an exterior angle formed. Okay, an exterior angle is outside of the triangle. The remote interior angles, okay, remote means not touching, like remote control, right? You can change the channel without touching it. So the remote interior angles are the interior angles of a triangle that are not adjacent to the exterior angle. So an exterior angle is adjacent to one of the interior angles, right? The angle that it touches, adjacent. So its remote interior angles are the 2 angles that it does not touch. So this guy is the exterior angle, this guy here, and this guy here are the remote interior angles. Now the reason that those are important is because of the exterior angle theorem. The exterior angle theorem says the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So in terms of my picture here, the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Okay? Now, the reason this has to be true without getting into a legitimate proof, we know that this angle right here has to be 180 minus whatever these 2 angles are, right? And we also know that this angle right here has to be 180 minus whatever this angle is. So we can actually tell that 1 has to be the same as 2 plus 3. The exterior angle theorem. Okay, this is an easy theorem to forget about, but often saves a lot of time. So when we extend one of the sides of a triangle, the angle that's formed is equal to the sum of the remote interior angles. So an exterior angle is equal to the sum of the interior angles that it does not touch. All right, example 1, we're asked to solve for x. We're told the measure of angle 3 is 55, the measure of angle 1 is x plus 20, and the measure of angle 2 is 3x minus 5. We notice here that 2 is an exterior angle of this triangle. The exterior angle theorem tells us that the measure of angle 2 is equal to the sum of its remote interior angles, which are 1 and 3. And we know what 1, 2, and 3 are, so we substitute and solve for x. So we get x equals 40. Okay. Exterior angle equal to the sum of the remote interior angles. Example 2, we're asked to solve for x and y. Let's fill in the information we're given. BCE is 46 degrees, and BAE is 36 degrees. Okay, generally, we want to try to solve for x first in these problems. So I'm looking down here at x, and I want to know how to solve for it. I notice that I've got parallel lines, right? These arrows tell me parallel. And I notice that x is an alternate interior angle, right? If these lines are parallel, this guy's the transversal. So we've got alternate interior angles. And we know that when we have parallel lines, alternate interior angles are congruent. So x is actually equal to 36 degrees. Now for this angle right here, y, okay, I notice that y is an exterior angle of this bottom triangle here, okay, and an exterior angle is equal to the sum of its remote interior angles, so y is equal to x plus 46, but we know that x equals 36, so y is equal to 82 degrees. All right, in this example, we're asked to solve for x and y, and we've got a right triangle. And we are given that the measure of angle HJK is 125, so let's fill this in. Okay. Now, generally, when we see angles or sides that have both x and y in their equations, our first instinct should be that we're going to have to write two equations and then solve the system. So one thing I notice about this triangle, we've got a right triangle, and we know that the acute angles of a right triangle have to be complementary. In other words, they have to add to 90. So we know that x plus 2y plus 2x plus y equals 90. And if I clean that up a little bit, we get 3x plus 3y equals 90. But again, there's a problem with this equation, right? Because we've got two variables and only one equation. So to solve for two variables, we need two equations. So we need to figure out what another equation is. Well, I notice that they give me this angle 125 here, and it's an exterior angle of this triangle. So 125 has to be equal to the sum of the remote interior angles, so 90 plus x plus 2y. So 125 is equal to 90 plus x plus 2y. So that gives us x plus 2y, subtract 90 from both sides, equals 35. So now I've got two equations with two variables. I can solve these in a variety of different ways. I think I'm going to use substitution here, so I'm going to solve this equation for x by subtracting 2y from both sides. So 35 minus 2y equals x. And I'm going to take that and plug it in for x in my other equation. So now this equation becomes 3 times the quantity 35 minus 2y plus 3y equals 90. So this gives me 105 minus 6y plus 3y equals 90. 105 minus 3y equals 90. So negative 3y is equal to negative 15 after I subtract 105 from both sides. So y is equal to 5. After I solve for y, I want to take it and plug it back into this equation so I can solve for x. So we get 35 minus 2 times 5 is equal to x. 35 minus 10 is equal to x. So 25 is equal to x. Now let's just sort of check ourselves and at least make sure that these two angles are complementary. 2x plus y would be 2 times 25 is 50, plus 5 is 55. X is 25 plus 2y is 10, so 35, 35, and 55 do add to 90. Example 4, we are asked to solve for x and y again. So to solve for x here, I sort of focus on this triangle, and I know that this is a right triangle, so we know that its acute angles have to be complementary, so 40 plus x has to add to 90. So we know that x is 50. Okay? Well, now that we know x is 50, we can focus on this triangle, this red triangle. But now we know that x is equal to 50, so we know that y plus 50 has to equal 90, because they are the acute angles of this right triangle. So y is equal to 40. Homework assignment, and that's the end of this lesson.